Hello friends, welcome back to ElectriVerse. Here we understand electrical engineering in simple language, with real plant examples. If you are new to the channel, remember one thing. Here, theory is not just theory. Here, we discuss those points that are understood only while working on the plant. Those things that are usually obtained from OEM trainings, paid workshops, or senior engineers' experience. In the previous episode, Part 7, we understood the PID loop in depth. We saw that if P is too high, the system can become unstable. If I is slow, the system reacts late. If D is not used correctly, noise increases, and equipment like pumps, fans, compressors start hunting. People often blame the drive is causing the problem, but the issue is incorrect tuning. Today, we are going to discuss a topic where clarity is very important. The topic is VSD versus soft starter. In every project, in every tender, in every meeting, this question is asked. Should we use a soft starter or VSD? Often, decisions are made based on feeling, not engineering. Today, we will do a simple, clear, step-by-step comparison so that you always know which option is best in which situation, based on cost, performance, and reliability. Let's go, friends. Let's do a small recap so that the whole picture becomes clear. In part 1, we saw what VSD actually is, cleared the confusion between VFD and VSD, and understood what the real logic behind speed control and energy saving is. In part 2, we went inside the drive, how the rectifier converts AC to DC, what is the role of the DC bus, how the IGBT inverter works, and how PWM converts fixed frequency to variable frequency. In part 3, we understood the control section. What is a reference? What is feedback? What is the difference between open loop and closed loop? And what is the actual use case of scalar and vector control? In part 4, we went to understand the relationship between motor and load, torque speed curves, pumps, fans, conveyors, crushers. Every load behaves differently, and how VSD handles them. In part 5, we saw that if motor parameters or auto-tune are not correct, then the drive can never give its full performance. In part 6, we learned how to use the ramp, S-curve, multiple speeds and jog functions to operate the process smoothly. In part 7, which was very critical, we broke down the PID in detail. Step response tuning, settings of pump, fan, level, and pressure loops, integral windup, and how proper tuning can change the behavior of the entire plant. And today, in part 8, we will take a bit of a zoom out. Is it always necessary to install VSD? Or in some situations, is a simple soft starter the best engineering choice? This clarity is very important, and today we will understand this clarity in detail. First of all, understand it in a simple line. The soft starter's job is to make the motors starting smooth, and VSD's job is to control the motor's entire life. The soft starter mainly reduces the starting current, reduces mechanical jerk, and provides a slightly adjustable starting torque. The motor will still run at full speed, just the starting is smooth. The role of VSD is not just to give a soft start. VSD provides speed control, torque control, protection, energy saving, and keeps the process stable. What is the problem in the real world? In many plants where only smooth start is required, people also install VSD just because it looks modern or shiny equipment looks good. And it is the opposite too. Where precise speed control is necessary, they fit the soft starter to save costs. What is the result of this? Either over-engineering occurs? Yes, it comes under protection. Today we will learn how to avoid these two mistakes. Let's go, friends. First, let's understand the soft starter with full respect. Because in many applications, the soft starter is the best solution. The basic principle of a soft starter is simple. It gradually increases the voltage when starting the motor. This keeps the starting current under control, and the starting torque also becomes smooth. This is usually done through phase angle control or a similar technique. Now, imagine a situation. A 400 kilowatt motor starts directly online. During starting, this motor can draw 6 to 7 times the full load current. This can cause voltage dips in the system. Lights may flicker, neighboring motors may be disturbed, and unnecessary stress is placed on the transformer. If we start the same motor with a soft starter, the starting current can be controlled to around 3 to 4 times the full load current. The system behaves more smoothly. Mechanical shock is very minimal. Pipelines, couplings, shafts all experience very little impact. But always remember an important point. The role of a soft starter is limited to just starting and stopping. When the motor reaches full speed, the soft starter is bypassed and the motor runs directly connected to the grid. That is, once the motor reaches running speed, there is no speed control, no energy saving at part load, and no automatic control possible based on process feedback. A soft starter only provides a smooth start and smooth stop. That's all. Now let's move on to VSD. VSD soft starter is not an upgraded version. It is a completely different philosophy. When you use VSD, you control the frequency. Frequency control means speed control, and speed control means torque control. The result is full control over the motor's behavior. VSD gives a clear message to the motor. The motor thinks, I'm not running according to the grid now, I am running according to the operator. When to run fast, when to run slow, when to ramp, when to hold, all decisions are made by the drive. VSD system makes it dynamic. Through PID, you can maintain level, pressure, flow, temperature, all. You can run the motor at underspeed, overspeed, where allowed. You can set torque limits, prevent stalls, and protect the motor according to the process load. The simple meaning is, where it is necessary to actively control the process, a soft starter is never enough. There, VSD is the real solution. There, VSD is the king. Let's go, friends. Now let's talk about some numbers. Engineering is never complete without numbers. Start directly online. Starting current is normally 6 to 7 times the full load current. Starting torque is 1.5 to 2 times the rated torque. And mechanical shock is quite high. Soft starter. Here, the starting current can be controlled around 3 to 4 times the full load current. Starting torque is proportional to the square of the voltage, meaning the torque is also smooth. Mechanical shock is medium to low and can also be adjusted. VSD start. Starting current is normally 1 to 1.5 times the full load current. Torque is completely controlled according to the speed and through V/F control or vector control. Mechanical shock is almost zero, a completely butter smooth start. Now, how to decide? If your system has a strict voltage dip limit, such as a weak grid, genset operation, या long cable feeders, तो VSD clearly better choice है. लेकिन अगर सिस्टम स्ट्रांग है, सिर्फ मैकेनिकल जर्क को कंट्रोल करना है और मोटर हमेशा फुल स्पीड पर ही रन करेगी, तो सॉफ्ट स्टार्टर भी बिल्कुल सफिशिएंट हो सकता है. नाउ वी कम टू द मोस्ट क्रिटिकल पॉइंट, process control. A soft starter does not control any process variable. Its role is only to make the motor's starting and stopping smooth. Once the motor reaches full speed, the soft starter becomes almost blind. It does not have real-time information about the process, and it cannot adjust speed or torque. Imagine a simple example. You have a booster pump whose job is to maintain discharge pressure. Sometimes demand will be high, sometimes demand will be low. If you are using a soft starter, the pump will operate in only two states, either at full speed or off. What will be the result? The system will turn on and off repeatedly, then turn off, then turn on again. Pressure will hunt, valves will cause throttling losses, noise will increase, and surging may start in the pump. All these problems come free of cost. Now, what happens in VSD? You directly feed the feedback from the pressure transmitter into the drive. You enter the set point. You enable PED. After that, the pump speed keeps adjusting automatically. Pressure behaves like a smooth line. The motor's life increases, and the system's energy consumption becomes quite low. The conclusion is very clear. where the process variable needs to be controlled continuously, such as flow, level, pressure, or speed, soft starter cannot be used. VSD is mandatory there. Let's clear a very common misconception now. Many people think that installing VSD, variable speed drive, will save energy. But what is the truth? Energy saving occurs only when your load benefits from speed reduction. For example, centrifugal pumps and centrifugal fans. In these loads, the power requirement is proportional to the cube of the speed. The simple meaning of this is that if you reduce the speed from 100% to 80%, the power consumption can be reduced to almost half. Here, VSD becomes a goldmine. The speed is reduced, energy consumption decreases, and the electricity bill also becomes significantly lower. Everyone is happy. However, if your load is of constant torque type, such as a conveyor, positive displacement pump, screw compressor, or extruder, then the energy savings are not as dramatic. VSD still provides benefits like soft start, torque control, better protection, and process flexibility, but just expecting the electricity bill will be halved, this will be incorrect. And the soft starter? Apart from starting, a soft starter does not provide any energy saving. The motor will run at full speed even if the process only requires 50% flow. That is why in many plants, the mistake is that they first install VSD just for the sake of energy saving without analyzing the load type. And later they say they did not get payback. They did not get payback because the calculation was wrong. Let's understand another hidden factor: mechanical stress. At direct online start, a sudden jerk is applied to coupling, gearbox, belts, chains, and shafts. It's just like releasing the clutch suddenly in second gear of a vehicle and giving it a race. This shock significantly reduces the life of mechanical parts. A soft starter controls this jerk to some extent. The start becomes smooth. But remember, the motor always runs at nominal speed. Therefore, each start is a mechanical event where stress continues to act on the system. Now, what does VSD do? In VSD, you can keep the ramp completely controlled. You can give a smooth S-curve start. For heavy inertial loads, you can set a slow start. You can limit torque. You can control direction. All these together act as a kind of insurance for mechanical life. If your plant has heavy conveyors, crushers, long belt systems, expensive gearboxes, or vertical pumps, then the mechanical benefit of VSD, it is very big. And many times, this mechanical benefit becomes more valuable than energy saving. Now let's understand a sensitive topic: harmonics. In normal operation, a soft starter bypasses. This means that in steady state, the harmonic impact of the soft starter is almost zero. Only during startup there is some distortion, which lasts only a few seconds. The operation of VSD is different. VSD always draws power through the rectifier and DC bus. This results in continuous harmonics. Due to these harmonics, transformers, cables, generators, and the entire system experience extra heating. Voltage distortion can increase, and unwanted currents may flow in the neutral. Therefore, where power quality is already weak, or where the plant has many drives installed, VSD selection must be done carefully. Input chokes, harmonic filters, multi-pulse arrangements, or active front-end technologies must be considered. In this case, the soft starter is a cleaner neighbor. The impact is only during startup, and the duration is very short. That's why it is necessary to decide at the design stage how many VSDs will be needed, what the connected load in kilowatts will be, what the system impedance is, and what harmonic limits are allowed. Now let's talk about protection and diagnostics. Here, VSD clearly wins. Soft starters provide basic level protections, such as overload protection, phase loss, phase unbalance, and sometimes ground fault. However, deep diagnostics, event logs, trending, or advanced thermal models are normally limited. The world of VSD is completely different. VSD becomes a small digital protection center. It offers advanced models for motor overload. Stall detection is available. Earth fault and ground fault detection are available. Over voltage and under voltage monitoring are provided. Temperature monitoring is available. Fan life alarm is given. Capacitor aging indication is provided. Trip history is available. And each fault has an exact timestamp. If you like root cause analysis, if you want to improve plant reliability, if you want to implement predictive maintenance, then VSD becomes your powerful partner. Soft starter will normally just say, trip occurred, reset it. VSD will tell you when the trip happened, at what current it tripped, at what voltage it tripped, and under what condition it tripped. Here, the difference becomes very clear. Now let's also understand a practical factor, cost. In the real world, cost always influences the decision. The initial cost of a soft starter is normally low. It requires less space in the panel. Programming is simple, and maintenance is comparatively easy. The picture of VSD is different. The initial cost is high. It requires more space in the panel. Cooling requirements are also higher. Programming is somewhat complex, and technicians need proper training to handle the drive safely. Therefore, if the project budget is tight, the load is simple, the speed will always remain constant, and the only goal is to avoid starting jerk, then a soft starter is a smart and economical choice. But if you want to optimize the process, save energy, protect equipment, require diagnostics, and need flexibility in the future, then the additional cost of VSD is not an expense. It becomes a long-term investment. Now, friends, let's look at two real field stories. These stories make it very clear in which situations a soft starter is the best and in which situations VSD becomes mandatory. Story number 1. A soft starter is the best choice. There was a chilled water pump system. The pumps operated only on an on and off logic. Flow balancing was done manually with valves. There was no requirement to change the speed in the process. There was only one problem. During startup, the LV network would get disturbed. Voltage dips would occur and stress would be put on the transformer. Here, the solution was very simple. Soft starter. After installing the soft starter, the starting current reduced to less than half. Voltage dips were controlled. Transformer stress reduced, and no additional complexity was added to the system. In this case, installing VSD would have been overkill. The requirement was simple, and the solution should have been simple too. Story number 2. VSD is mandatory. There was a booster pump system. जहां सिटी प्रेशर मेंटेन करना था, डिमांड डे टाइम और नाइट टाइम में बहुत ड्रास्टिकली चेंज होती थी. वहां पहले डायरेक्ट ऑनलाइन स्टार्टर्स थे. पंप बार बार ऑन होता, फिर ऑफ होता, प्रेशर में स्पाइक्स आते, पाइपलाइन में हमिंग साउंड होता, वाल्व्स जल्दी वेयर आउट होती और लोग कंप्लेन करते रहते. फिर सॉल्यूशन चूज किया गया. एक ही पंप पर VSD इंस्टॉल किया. प्रेशर ट्रांसमीटर का फीडबैक ड्राइव में दिया. सेट पॉइंट फिक्स किया और PID इनेबल किया. पंप स्पीड ऑटोमेटिकली एडजस्ट होने लगी. डिमांड के हिसाब से मोटर स्लो भी होती और फास्ट भी होती. रिजल्ट बहुत क्लीन था. प्रेशर एकदम स्मूथ हो गया. नॉइज खत्म हो गई. वॉल्व्स की लाइफ इंक्रीज हो गई. एनर्जी बिल रिड्यूस हो गया और कस्टमर कंप्लेंट्स ऑलमोस्ट जीरो हो गए. यहां सॉफ्ट स्टार्टर बिल्कुल यूजफुल नहीं होता क्योंकि प्रॉब्लम स्टार्टिंग की नहीं थी. प्रॉब्लम प्रोसेस कंट्रोल की थी और प्रोसेस कंट्रोल के लिए सॉल्यूशन सिर्फ VSD ही होता है. लेट्स गो फ्रेंड्स. नाउ लेट्स क्रिएट अ फाइनल क्रिस्टल क्लियर डिसीजन चार्ट. You can confidently use this chart in project meetings. First of all, when should you choose a soft starter? If the load is always running at a constant speed, if you only need to control the starting current and want to reduce mechanical jerk a little, if power quality is not critical, if the project budget is tight and there is no requirement for closed loop control in the process, then a soft starter is the right choice. Now let's see when to select a VSD. If the motor speed needs to change continuously according to the process, if there is a clear potential for energy saving, especially in pumps and fans, if you want to reduce mechanical stress and improve equipment life, if advanced protection, diagnostics, and PID control are required, and if the system is ready to manage harmonics, then a VSD is mandatory. Now listen to a bitter truth as well. Many times in the industry, decisions are not made based on engineering analysis, but by observing the brand or following fashion. This is the reality. Some common mistakes are found in almost every plant. First mistake, installing VSD just to look modern, whereas a soft starter is completely sufficient. Second mistake, installing a soft starter only to save costs, when in the process, level control, pressure control, or flow control are critical. Third mistake, ignoring harmonic study and installing many drives without planning. Later, transformers heat up, voltage gets distorted, and the system becomes unstable. Fourth mistake, not providing training to technicians, treating the drive as a black box, and when a fault occurs, everyone gets confused. The meaning of proper engineering is not just choosing one thing, but looking at the entire system. What is the load demanding? What is the process requirement? How much does the budget allow? What is the power quality? And how will long-term reliability be maintained? Neither overkill nor compromise, just the right fit. Let's go, friends. Now, let's quickly recap what we covered in Part 8. First of all, we understood the real role of a soft starter. A soft starter only provides smooth start and smooth stop. Continuous speed control is not a function of a soft starter. Then we saw the real role of VSD. VSD provides complete speed control, torque control, process control, protection, and advanced diagnostics. We compared the numbers of starting current and starting torque. We clearly explained what the difference is between direct online start, soft starter start, and VSD start. We moved on to process control, pumps, fans, level control, pressure control. Where the speed needs to be continuously adjusted, VSD is the king there. We also clarified the real truth about energy saving. Energy saving is only a real game changer in centrifugal loads. In constant torque loads, energy saving is limited. Mechanical stress, gearbox life, pipeline health, and in heavy conveyor systems like systems, the benefit of VSD is very significant, sometimes more than energy saving. Talking about harmonics and power quality, soft starter is clean in steady state. VSD is powerful but also demanding. Proper harmonic planning is essential. We have also seen real field examples. One case where a soft starter was the best and simplest solution, and another case where VSD brought about a revolutionary change in the entire process. And finally, we made a clear decision, matrix. Which system to use when understood in very simple and practical points. Now, if someone asks you VSD is better or soft starter is better, your answer will be very clear. Better is not the one that is more costly. Better is the one that fits right for the system. Friends, this was part 8 of the VSD series. VSD and soft starter, the most honest, practical, and real engineering comparison. I am fully confident that now in any project discussion, you can confidently say which place a soft starter will be best and where VSD will be mandatory. And this decision will be based not on guesswork, but on pure logic. ElectriVerse's one goal is to give engineers the clarity that will take their careers to the next level. If you found this video valuable, please like it, share it in your plant's WhatsApp groups, and subscribe to the channel. In Part 9, we will bring another deep topic. The real truth about harmonics with VSD. What is THD? Why transformers and cables get hot? And how line reactors, passive filters, multi-pulse systems, and active front-end drives keep the entire system healthy. You've been watching ElectriVerse, where every spark tells a story. Stay charged, stay safe, stay happy.